Hello everybody, and today I am going to talk about my long-awaited video. Well, I've awaited it a long time. I don't know about you guys, but for multi-instance fixtures in Unreal Engine. Now, I was able to show you guys how to build basic fixtures. Multi-fixtures, it gets a little bit more complicated and kind of dives headfirst into more game development than it does lighting design. So I'm going to go over a couple terms to start everybody off because this is kind of a meeting of developing and lighting design. So I know probably half my audience is going to be versed in one and half the other. This first multi-cell fixture, the 8-cell that we're going to build, is available on my Patreon as a download if you want to subscribe and pick that up as a reference or just to get rolling. And then you can also pick up this Nexus 5x5 panel that isn't available anywhere else. And it's a very high detail model. I even put the LED diodes in there, but I put it as a texture so that it doesn't take up all that mesh and reflection data. So check that out if you're curious. And Discord is up as well. So I've got a showroom where you can show off some of your fixtures, community support where you can get support from other people, video stream channels where you can stream your screen to get help from supporters. So check that out if you get a chance as well, and let's get into this video. A moving head is a light that's typically used in the entertainment industry that can pan or tilt and point at any specific point in the room that's below it or above it, depending on how you hang it. And how you control that light is with DMX control, and that comes from either a network port or from a DMX plug. But basically, DMX is the protocol for communicating with mostly any light fixtures, and you could also control media servers with it or videos. So if you want to see more info on that, look up ArtNet or streaming ACN. Those are network-based DMX, whereas a normal 5-pin DMX cable, it comes from network, but by the time it spits out, it's not a network-based signal. The head is the part of the light that contains the lamp, and they usually have set pieces preset for you, and so it's made to work quickly so that you can quickly get your system up. Because of that, it's very engineered, and they have usually a pretty big library of stuff to choose from, and they keep it pretty up to date. Now that's going to differentiate from our Unreal world, because Unreal is the opposite of everything I just listed. You don't see the light output naturally in a way that is economic for your system to handle 20 to 100 lights. You have to set it up for DMX control, and you have to kind of bring in all the meshes one by one and build some of these. You don't have to build the fixtures. You can use something like Carbon for Unreal, or you can use the native DMX fixtures that are built in, and those will get you up and running faster. But what we're doing is building these fixtures almost from scratch. We're using some of the Unreal's tools to build these fixtures. So to make up a 3D mesh, we have vertices and points, which are just any intersection that can represent an intersection between one or more edge. And so an edge is two vertices connected together by a line. If you have 3 edges and 3 vertices or more in one shape, what you get is a face. And that face, once it becomes a face, does a little bit more than an edge or vertice, because an edge or a vertice cannot be seen as it doesn't take up any 3D space. It cannot receive light or cast a shadow. But a face can. And if you get multiple faces together, what that makes up is a mesh, which can be a 3-dimensional object. Now note that with faces, they have to be facing the correct direction for light to reflect off of it. If the face is facing the wrong way, the light and camera will simply pass through it. Here's what I mean by pass through it. So the face is the current industry standard of representing a mesh. And so if we want to make a tree with our face, it would take up lots of different triangles. And so in our 3D scene, we will always have a camera. And the camera is set to a certain number of pixels to render. So in this case, 1920 by a 1080 screen. So it has 1920 by 1080 pixels across, just like this single hole that we're about to fill in with information. So if we take that one single pixel and shoot it out of our camera at the focus, at the angle that it specifies, we'll eventually hit this tree. Once we hit the tree, we know that we hit something, and so we gather the material info to decide what we're going to display on that screen. And so the material of that tree might be called something like m_tree, just for example. And that texture information, that file, or the material has all of this information that includes the texture. And so the texture might be a leaf that we hit. And so we know that we hit a certain spot on the UV space to decide what part of the leaf to get. Otherwise, we wouldn't know. We might just all be returning complete leaves every pixel, which doesn't make sense. So we have to be able to get a certain pixel of the texture that it's providing. And then in addition to that, we also get other information like the red, green, and blue values, and then the roughness or metallic values that we specified with our textures in a previous example. And so if we take all of this information and render that pixel green, and we do this for every single pixel in the scene, we could eventually end up with an entire scene. That is how the premise of 3D rendering works. Now, to keep every individual leaf's texture of every tree rendered at all times would cost an exorbitant amount of memory. So what we would often do is for the trees that are very close by, we would be using leaf textures. But for the trees that are very far away, we might go through a process where we pull away this texture and instead give it just a tree branch or even an entire tree. And what this does is it drastically reduces the number of textures that are being used in the game so that we can have more performance and better frame rate and focus on the trees that are actually up close. The emissive color is the color or image that does glow. So light hitting it won't really do anything. That's going to call its base color. But this is going to emit light and it's going to glow in a dark world. And in Unreal Engine 5, actually, if you have Lumen enabled, it's going to emit light. And you'll actually get some environment light from it. UV maps are a little complicated, and I'm going to demonstrate them more. But I want you to imagine you have a 3D object like a digital sculpture. To make it look realistic, it needs textures, right? Textures are like the skin of your 3D object. They can be anything from colors and patterns to detailed images. But how do we wrap this flat texture around a complex 3D shape? So that's where UV maps come in. Think of a UV map as a blueprint. It's like taking your 3D model and unfolding it onto a flat surface. This process is similar to peeling an orange and laying out the peel flat, or unfolding a cardboard box, or wrapping a present. In 3D modeling, every point on your 3D object is mapped to a point on a 2D texture. These points are referred to as U and V coordinates, hence the name UV map. So why is this important? Because without a UV map, applying textures to a 3D object would be chaotic, like randomly painting an object without a plan. The UV map ensures that the texture fits perfectly on the model with every detail in the right place. So creating a good UV map is an art. It requires thoughtful planning to minimize seams, distortion, and wasted space. And it's a crucial step in the 3D modeling process because it directly affects how realistic your model will look. So a texture then is a image file. PNG, images work or JPEG images work. And then baking is a method used in Blender, but it's used in other softwares as well, of building something that's usually pretty complicated and then condensing all of those, all of that information down into usually one or two different textures or one or two different images. So I put together this small sample to show you guys kind of what a material is. On the left side of this material, I have a solid red texture. It is a rough texture, so it's a very matte finish. So it doesn't matter how you look at it, it's basically going to look red at all angles. Versus our second material here, the second material is a kind of gold texture, so it's yellow, and it is high in metallic properties. So depending on that light hits this is how bright or dark it's going to be. So you can see I kind of tried to simulate that in PowerPoint. So when I bake these to one material, my goal here is to get the following. I want one base color because everywhere on this cube corresponds to a flat texture. So I'm going to get this as my base color, and it's going to be red and yellow. My metallic map is going to be a different texture generated, and it's going to tell it that on the left side of this shape, it's not metallic at all. On the right side of this shape, it is somewhat metallic. It is about probably 60% metallic. And then another map that we would generate is the roughness map. And so with this one, it would say, okay, where is this rough? Because we know how to handle the light on rough objects. Well, it's rough on the left side by about 50%. And then on the right side, it's not rough at all. It's smooth. One note that I had is that on this, I said I would get to this. When I say that meshes are the industry standard method of showing 3D objects in a computer simulation, the alternatives to that right now, which are somewhat new, point clouds aren't that new, but 3D Gaussian splatting and NVIDIA nerfs are pretty new as they use a bit of AI to help assist in their rendering. I don't exactly know all those details, and that's not what this video is about. So some of the things that we're going to need to build for our multi-instance fixture is a head. The head is one of the more important meshes, and it's going to contain the light. And it's going to be in almost every multi-instance fixture. Optionally, you could also put a yoke and a base on that head. The yoke is going to be what holds the head in place, usually by arms, and then a base is what connects to the yoke and gives it a heavier attachment to sit on. The other thing we're going to need is a clean UV map for the head. So in this case, a more rectangular head. I have the top rectangle being the face, and that face is given a very clean UV map to project on. It's centered, and the edges align perfectly with the edge of the UV map, and I'll show you how to do that. And I like to do that because I like to, in my blueprint, solve where the UV light goes mathematically, and if the UV points are in from the sides a little bit, not true at the 0 and 1 points, and they're just estimated in, then it makes that math difficult. The other option is you can use two materials, and the UV space of the head or of the face is going to take up 100% of the UV space. The body is going to be on a different material in this case, and you don't have to tuck the body UV space to the side. Again, I'm going to demonstrate all of this in a bit. So this is a video of me kind of making this. So you start with a cube, and then I'm going to hit SZ to make it kind of flat, and then SY to make it look more like a fixture. And then I go into my UV editing tab, And what I'm going to do is I need to select edges first and mark some seams. So I'm going to go to UV unwrap. I'm going to select my top face and I'm going to hit unwrap, and that's going to fill 100% of the space. I'm only going to hit S and Y to scale it down and give me some room for my body. So now I'm going to hit A and then hold Control and click my face with faces selected. So it deselects my face. And then I'm going to turn all of these faces into a seam, or all of these edges into seams, except for one of those, and one of the bottom ones. And what that'll do is let the body join with, let the sides join with the bottom face, and let that be one unit instead of two pieces. So I'm going to, with those faces selected, hit unwrap, and then scale that down to be really small, and then move it toward the bottom or the top. And then as it's, what I had here isn't fine. That top part of the fixture would glow. And so I just want to move it down and keep it out of the way of the fixture. Again, it doesn't have to be very big or have much detail because it's just the body. It's going to be, for the most part, ignored. It could almost have no texture if you want. And so the texture that we're trying to make, and I'll show you this texture eventually, it is going to look like this. Your center part is going to be kind of your designated face space. You don't want this rotated. You want it straight because you're going to be adjusting the X and Y position to get this lit pixel here, the white one. You're going to try to get that over the rest of your pixels. So in the blue zones here, you put any geometry that's relating to the body. In the black zone, you put any geometry relating to the face, and the white zone that you see is only one pixel of your fixture lit. So if it's an 8-cell fixture, you divide your shape into 8 pieces and light up just one of those faces. It doesn't matter how it gets done, actually, which I'm about to talk about, as long as you have one pixel out of your 8 lit. And so here is where we get to a sort of dividing point. You're about to see why this got so complicated. Because to generate that texture, we can have two methods. There's the baking method, and then there's using Photoshop. With the baking method, there's some pros and cons. The pros are that the mesh that you're importing dictates the placement of the texture itself. So there's no needing to match this up, match the texture up to the mesh or to the mesh's UV map, because one creates the other. So you get very accurate placement. And then you can incorporate your exterior lighting, like say if you build a complex mesh and then you have lights and shadows that you don't want to have to render in Unreal Engine, you can incorporate lighting from the from your Blender scene into that texture, and it'll carry over. And so you get very detailed and realistic textures with 100% accurate placement. And once you get a system in place, if you want to make more fixtures, it scales up pretty easily. What I have had finicky results with is scaling like something into higher complexities, but we'll get to that. So the cons of this, of baking lighting into your texture, are that it's somewhat time consuming to set up, but I'll show you guys. And it is going to be GPU and CPU intensive. It's also somewhat problematic. Almost every time I've set it up, I've had some sort of issue that I've had to go in and fix. And then if your workflow changes, it could also it's difficult to maneuver. And then it uses very in-depth aspects of Blender. So if you don't already know Blender and instead you know Photoshop very intimately, I would use Photoshop, honestly. Because Photoshop, one part, and I'm not very good at Photoshop, I'll be honest. One thing that is kind of difficult for me doing the Photoshop method is that it requires an outline of the UV map. And I have trouble getting that down to the pixel exactly. Honestly, what I do, my way of doing it is to go to the UV editing tab and hold Windows Shift S and then grab right here, grab the entire texture, and then take that into GIMP or Photoshop and scale it to be right on the line, and then make my changes. But that's not a very good way. So if you know Photoshop well, once you get this outline, it's a very straightforward process. You can do whatever you want to make that texture, and it's also very cheap on your CPU or GPU. But it might not scale easily. If you have a lot of meshes to do, it might take a while. Some cons of this method are my textures end up somewhat off placement, and you saw my method, so it makes sense that would happen. And then it also uses pretty in-depth aspects of Photoshop. So this just cons of this process is that it uses in-depth texture processing. And so it's about to get even more complicated because there is different types of lamps. Now, I'm going to start with a slightly different method, but there's just different lamps you need to be aware of. There's the Cobb LED, which is this top one here, where one source of light in a huge rectangle or in a huge reflective sort of zone bounces back and forth and eventually emits out. There's also the plate type, where it's kind of a large plate of LEDs and it doesn't reflect off of anything. So in the first one, baking light is necessary or is helpful because you can get those accurate reflections. In this plate type, like the JDC1, Photoshop is actually a pretty good bet because you just need a white plate, basically. There's no reflections happening. On something like the X4 bar, it's kind of doesn't matter. There's a lens in place that hides some of this pixels down here, that hides some of the drawings that you do. So that gets a little bit complicated. And then there's incandescent lamps, which honestly I haven't done yet. But I would assume that it would be a process similar to Cobb LEDs, where you would have to probably need to bake it in. If you're dealing with something like a PAT, you would definitely want to bake it in because you want all those accurate reflections. Whereas something with a blinder, you could probably get away with the Photoshop method of just putting a white cell with like some coils or something. So we have our types of lamps, and we have other necessities like how we generate that texture. And then we have our application, and it's another variable in the mix. So if we're doing a fixture demo, like I said, we would want to use a lot of detail in both the face and the body. And we would want to use high resolution textures. A little bit less quality from a fixture demo would be a client show rendering, where you're showing them what a show is going to look like, and you're using Unreal Engine to do that. And so you would want to balance your quality with your frame rate. If you have everything in super detail, you're not going to have good frame rate, and your project might not be completed on time, to go a little bit further. And so you could use lower texture resolutions. You're probably not going to get that close in detail to one of your fixtures because your client's going to be looking at the bigger picture. And then there's low quality, which is something that would be used like a visualizer, where a technician is using it to pre-visualize one of their shows, and they care mostly about frame rate. They don't care if their fixture doesn't look very good or doesn't have good textures, or even if there is a fixture body at all. And so you would use different methods for that. And then there's a little method in between those, which would be like multiplayer experiences, where you would want, and I don't know how you would use DMX in this situation, but you would want things to look good because it would be similar to a video game. But you also wouldn't want, you would want to prioritize frame rate as well. And so you would kind of take a more stylistic approach, or like an animated approach to these lights. So what we're going to do is represent a 2D object. It's kind of strange, but you can still do that. You can make a mesh that's basically 2D. And so let's say we have a square. There is one face to it. It is a very basic mesh, and it has a UV map. What we're going to do is copy this and paste it, and then keep this basic mesh for later, because we want all of the dimensions to line up. We're going to turn this into a complicated mesh, and we're going to add some lights to the scene. So we added sort of a bevel corner, and then we raised up the center. And then you can see on one side it's pretty bright, on the other side it's somewhat dark. We're going to take this scene, and now it has 5 faces and 2 textures. So after the baking process, then we have a texture that is, say, 512 pixels by 512 pixels, and it looks just like what the camera saw, where it's bright on one side but dark on the other, except this is now a texture. There's no lights involved in the scene. And so we could take this texture and apply it to the basic mesh that we kept from earlier, and then what we get is a basic mesh with a complex texture. And now we could add one light to the scene and have one face, and it looks like it has 5 faces and a couple more lights. So now that you can see all of the different methods used to make multi-instance fixtures, you can see why it gets complicated when you've got all sorts of different eyes that have different needs, whether it's technicians looking to visualize their JDC1 with the center strobe that needs to be right down the middle and in a white color, or it's somebody with a budget that's looking to see exactly what the X4 and its lens will do to the space, both visually, as eye candy and as a wash light. And then you've got things like the Nexus panel where it's got a grid but it has no lens. And then you've got blinders where it's not RGB but it's all one color. And then you've got some lights where all 3 cells are included or encased in this cylinder, and one cell slightly impacts the other. So you might need to factor that in if it were a demo. You've got some DJ lights where they have an amber cell that needs to be factored in. And sometimes the amber cell is inside the LED that emits light, and that needs to be factored in as well. And then you've got some lights where the LED is separated, all of the LEDs are separated, but it's still a multi-instance fixture. And then you've got the jolt bar, which takes up 127 channels, and so that is just, those lights would get complicated. And basically everything except for this fixture, which I'm glad we don't have to touch. So now that you can see how complicated this is, I have a very intuitive method to explain this to you guys. I'm going to go from a potato level quality to a potato quality with a bunch of gadgets. And the gadgets are going to be things that save performance, maybe talk to each other a little bit, judge their depth and space to see what kind of quality that they need. And once we get all of those, then I'll move on to more soothing, well put together fixtures that have only the specifications and needs that they need. So I do want to get into the content, but I want to show you this overview before we start, because I think it makes it easier to follow along whether or not you're making something similar to what I'm making or totally different. The first essential part to this system is the blueprint. The blueprint ties all of the assets that we generate, whether it's through Photoshop or baking or modeling or whatever. It ties all of them together and makes them all communicate in a way that makes it look like a light. One key aspect of that is the mesh, which has geometry to it, and the blueprint references all of the meshes that are involved. Specifically on the light emitting mesh, though, the material that corresponds with that mesh is attached to that mesh. And the material I'm talking about is the one that's responsible for outputting the light. And so on that material, we have our base color texture for the light, which is usually just kind of a gray or black or white glassy filter. And then we have our emissive texture, which is the pixel of light that lights up for that given pixel. And so normally this would be all dark. Well, the what it receives would be dark, but you would still have a pixel's information there. And then the other optional part would be the refractive attribute, which only happens if you have a lens. And so we take all of this and apply a DMX system to our blueprint so that it can we can actually get DMX signals into it. And so all of these elements work together. The material or the textures do their math based on the instructions given from the blueprint, and then update the material, and then that updates the mesh, and then that updates the blueprint, and all of this updates physical properties like physical properties of the lights, like lighting, the pan, the tilt, the zoom, and what texture you use. And so the textures, we set that parameter by a string text, which I'll show you. But we have to use a string or text to set those parameters. The information that we're going to send is going to be all of the cells' color values in a vector parameter, each of them, and then all of the cells' zoom values in a scalar parameter. And so what that texture sample might look like, this is the emissive texture from on the left side of the slide. It's going to have a single pixel lit up. And we're going to multiply that by the color value that we have chosen for that pixel. And so if it's red, that's the texture that's going to be pushed to the fixture. And it's going to be added to the previous and the next pixel. And so cell 1 might look like this with a red value up. And then cell 5 might look like this. So the emissive texture is offset and moved so that it hits a different cell. And then you can multiply that by a different color. And so if we add these two resulting textures together, we get the look that we want to output onto the fixture. So all the other cells are receiving a signal, but it's a value of 0, 0, 0, so nothing lights up. And so this texture is what plugs into the emissive materials input. And that emissive texture turns from all black to now this red and green. And then if we update other things like the pan and tilt, then we can, if we have a light attached to that, we can direct where it points that light. And then we can even give it a zoom attribute with a very high quality option where it actually physically moves the lens position back and forth. But I'm probably not going to do that for 99 out of 100 scenarios. As for the light, the intensity actually stays pretty constant. So you can set that brightness, and you're not changing the brightness levels in the light. What you're changing is the RGB values that get fed to the light. So your intensity could be at 100, but if your RGB values are 0, you're going to get a light output of 0. That is it for our multi-instance fixtures in Unreal overview. And in the next video, we're going to dive right into building our first 8-cell LED strip fixture. Don't forget to subscribe to the channel before you leave, because I'm going to be upgrading this fixture and altering it as we go for a lot of videos to come, and I wouldn't want you to miss something. And if you like what you saw, please give this video a thumbs up. It really helps out the channel and helps me make these detailed videos like this for you. So thank you, everybody.